everyone. We're going to go ahead and get started. I'm Angie Jones, and I am a Senior Developer Advocate at Aptly Tools. I specialize in test automation and even blog about techniques and strategies around this at angiejones.tech. And you can find me on Twitter at techgirl1908. Today I want to talk about building trust into your continuous integration test. And I titled this, The Build That Cried Broken. When we look at continuous integration pipelines and all of the pieces that are there, we know that all of this stuff has to work in perfect harmony in order for us to have a successful build. But there's one little problem child in here. No matter what project you work on, it seems like the test piece is always the weakest link, especially when you mature beyond just your unit tests, but more of your functional tests. We see that sometimes these start breaking, sometimes they're breaking for no good reason at all, right? So it's not really a problem with the app. So that's what I want to spend time on today, talking about how to stabilize that piece so that you have a nice, trustable pipeline. And there was an ancient storyteller, Aesop, who used to tell fables and had a nice little moral to the story for the people. Who knew that Aesop, even way back then, knew a little something about continuous integration as well? So we'll look at some of his fables and figure out if we can get those morals to apply to us in our continuous integration. The shepherd boy and the wolf, also known as the boy who cried wolf, right? So there was this young shepherd boy, and he was responsible for taking care of the sheep in the village. And so he was a young kid, a prankster. He would sometimes just yell out, "Wolf, wolf," and all of the village people would come running to see what was going on. And then he would fall out laughing at these people who stopped what they were doing to come and run over, and he let them know it was just a prank. So they fell for this a couple of times, but after so many times, they learned to ignore his cries. Until one day, there really was a wolf coming. And so the boy cried out, "Wolf, wolf." And guess what? No one came. So of course, the sheep perished. Our continuous integration pipelines are much like this. We have our tests that are crying broken, broken, and the developers run over to see what's going on with the test, only to find that they've played a trick on them. There's nothing wrong with the application whatsoever, right? After so long, we stop trusting in these tests. We stop paying attention. We stop running over when they cry broken. I found myself in this situation once where our tests, we had lots of them. We had about 4,000 tests that were running. And they gotten to a point where a lot of them were crying broken and they weren't, and we stopped paying attention. The devs stopped paying attention. The automation engineers stopped paying attention. Everybody did. And then one day, someone from product wanted to demo a feature to a potential customer. So they went to show them the feature, and it was broken. And so, of course, product was embarrassed, and later on went to the test manager to say, "Hey, I thought we had scenarios automated around all of the stuff that I demo." And test manager said, "Yeah, I thought so too. Let me check on that." So the test manager came to us and asked us about it. And we looked through our tests, and sure enough, we did have automation for it. It was red. It had been breaking. But we stopped paying attention to this stuff a long time ago, so we missed that bug. So the manager said, "Listen, we can't operate like this. We have to get our automation under control. so that we know when stuff is failing for real. So I'll take you on this journey of how we did just that. The fox and the goat. So there was a fox that walked along a trail one evening, and he became thirsty. So he stumbled upon a well of water, and he jumped in and began to drink the water. Once he quenched his thirst, he was going to leave the well. But he'd gone too deep. He couldn't get out. So he kept trying and trying to climb his way out, and he couldn't. So he had to end up spending the night in the well. The next morning, a goat walked this same path, and he heard something from the well. So when the goat looked down to see what was going on, he saw the fox. He said, "Mr. Fox, what are you doing in the well?" The fox said, "Oh, I came to drink some water. It's delicious. Come on in. You should have some." So the goat jumped in. When the goat jumped in, the fox jumped on the goat's back and leaped out of the well. And then the goat was stuck. He looked down to the goat and said, "You should look before you leap." Now you see, we wanted to do continuous integration, and everybody told us the key to this was to automate your tests. So we jumped on in. We drank the Kool-Aid without looking first to see what did that really mean, right? So we just started blindly automating tests, and they told us you should probably even do it in sprint. So our goal was, let's automate all of the acceptance tests in sprint, right? We never stopped to think, what is the end goal? Why are we even automating? It's not just to automate tests. The end goal was to give fast feedback to the team. Well, we weren't operating like that was our end goal because we hadn't even realized it really. You know, it sounds like it makes common sense, but we lost sight of what our end goal was. And so in doing so, when you think about fast feedback, this fast feedback is supposed to be giving information to the team. All right. Well, we've automated these tests. These tests are read. No one's paying attention. And instead of fixing that problem, we just keep on automating and throwing stuff on top of these failed tests. What information is this providing? This totally goes against the end goal because no one is even listening to the information. The lioness and the vixen. So there was a lioness and a vixen, and they both brought their children out to play one beautiful day. Both of these were mothers, of course, and so they did like most mothers do, and they began to brag on their children to one another. And the vixen says, "Oh, my boys, they're so witty, so clever." And the lioness says, "Yeah, my boy, he's strong. His hair is nice." And then the vixen looks to the lioness and she starts getting a little competitive. And she says, "Well, yeah, your boy's cute, but you only have that one. You see, when I have mine, I have a whole litter of them." And the lion, she looked up, held her head high, and she said, "Yeah, I only have the one, but he's a lion." The moral of this story is quality over quantity. You see, we were just trying to automate everything in sight. We were driven by that metric of 100% acceptance test automated, not giving any consideration into what we were automating. Again, looking at the end goal of fast feedback, if we're automating thousands of tests, thousands of low-value tests, then this isn't providing quality information for the dev team. Not only that, it's slowing up the bill. We have all of these tests running, and sure, we can run these tests in parallel, but it's still much slower than it needs to be for the information that they need. So we had to take a step back and get rid of that silly metric of, oh, we want 100% of our tests automated. No, we need to automate the valuable tests, the ones that will give us information to let us know, do we stop this deployment or not, right? And not only do you only automate those high-value tests, the high-quality ones, you automate those with quality. Because the death of a continuous integration system is flaky tests. A lot of people talk about flaky tests. A lot of people say avoid them, but not many people tell us how to do so. So I'm from the school of I like to tell people how. So I'm going to spend a moment just talking about some techniques I use to get rid of flaky tests. One, you need to make sure you have stable identifiers. And this seems like common sense, especially if you come from my world of testing and automation. But I've worked with a lot of newer developers who just do not know this. This is not something that they've realized. So when building our applications, we have to make sure that they're testable. And one way to do that is to make sure that there's handles to the components and the elements that we're building so that we can automate against them, right? If you're doing the test automation yourself, don't just rely on the IDs alone. So this will get you most of the way, but we're in a world now where we're using all of these fancy JavaScript widgets, and sometimes we don't even have control over the identifiers on the elements. Or even if we do, there's situations where the elements are still present in the DOM, and there's all of this stuff going on where something may have not been visible before. It would be removed from the DOM, but now it's still in the DOM, and it's just all of this wizardry going on, right? So not only do we need to know how to find these elements by their identifiers, we also need to be aware of using XPath and CSS locators in those sticky situations. We also need to use intelligent weighting. So, of course, our machines run a lot faster than our humans do, right? So when we're writing this script, we say, oh, we click the button, and then we're going to click this button on the next page, right? But there's a slight delay when we get to the next page that we didn't really account for. And a lot of times, tests fail because of this whole waiting period. Well, the hard, fast, easy way to do this is to throw a sleep, thread.sleep in your code, right? Don't do that. We're no longer sleeping in code. It's time to wake up, all right? The reason for that is you find yourself chasing your tail. So you want to run this thing against multiple environments. On one environment, it takes 1.5 seconds for something to occur. On another environment, this one doesn't have as many resources, might take 2 seconds. On this other crappy machine that you gave the testers to use, this one takes 4 seconds, right? So what do you have to do? If you're going to use a sleep, you're going to have to use the greatest common denominator, which in this case is 4. Well, on that environment where it takes 1.5 seconds, you've now added this unnecessary increase. And it might not seem like a lot for one test, but remember, we had thousands of tests. So you keep adding this over and over, and it really starts to add up. Again, what's our end goal? Fast feedback. This doesn't go with that, right? So instead, use intelligent weighting. There's libraries that include things that will allow you to wait for conditions and things like that. If you're waiting, you click this button and you're waiting for some pop-ups, then wait for that pop-up. Wait for it to be present, or wait for something to disappear, or wait for the condition that you're actually looking for. And that'll save you a lot of time. Also, I always recommend consulting a source of truth. Let's say, for example, you were testing against a movie search catalog, right? And so in your test, before 2018, you wrote this test last year. And the test searches for Avengers, right? Well, 2 results would come back. And so in your test, you assert and say, I expect 2 to come back. You do the search and you compare the 2. Well, this year, the 3rd installment of that came out. So the test breaks. And you say, oh, yeah, duh, because the new movie came out. We'll just update the test to 3. Fair enough, except next year another one is coming out. So are you going to constantly chase this test like this? No, you should probably use a source of truth. Where is the information supposed to come from? We can use more resources in our automation code. Can you not use an API to see what it's supposed to be and then assert that the UI is actually showing that? Can you not use maybe a database call or something? Something that is probably faster and more reliable. And then finally, shortcuts. I love to take shortcuts in my tests. We see lots of times when we're doing UI tests, we automate everything against the UI when we don't necessarily have to. Let's take an example, a shopping cart example. Let's say the test is I want to test removing an item from the shopping cart. All right? If I think about that scenario as a tester would, they would go to the UI, they would probably search for some product, they would have a list of search results come back, they would need to look through the search results to determine which one they should choose, they would click on that one, and then they would be taken to the product page of that one, and then they'll need to click on the Add to Cart button, and then they'll need to click the cart icon, and then finally they're at the cart and can do the test itself, which is to remove the item from the cart. Well, that's fine from a manual standpoint, but when we're doing automation, that is really slow. Not only is it slow, you're introducing more opportunity for brittleness. Going through all of that, any of that can flake out on you, right? So I skip a lot of this stuff. I start looking for seams in the application. For example, instead of searching for a product, why do I care about searching for the product? A lot of times, these pages might have unique URLs. Why not just navigate right to that and skip all of that searching stuff? Or better yet, is there a web service I can call that adds this product to my cart? And then when I go to the UI, all I need to do is go to the cart page and begin my test. So I skip a lot of the things that are unnecessary. Not only does this speed up your test, but also if you remove a lot of the dependency. If search is broken, you don't want your cart test to be blocked because search is not working, right? You still want to test this functionality. So I'll include tests for search, but I'll also use seams in other places. There's no reason to exercise this same path over and over. Have you ever had multiple tests fail after you checked in something? You looked at all of the tests and they all told you the same thing, that you broke this one thing? Right, that's noise. I call that noise, it's redundant. So we want to try to avoid that. Story time. The astrologer. So there was this astrologer, he was a really deep guy, right? He would only come out at nighttime, and he would look into the sky, and he would gaze at the stars, and he was able to predict the future this way. He wouldn't speak to anyone in his path. His only focus was here, predicting the future. Well, one evening as he was gazing into the sky, he fell into this black hole that was in front of him. Everyone laughed at him and told him, hey, you're looking to the future, you should probably look at what's right in front of you. So as we're doing our in-sprint automation on my team, we were so focused on new development. Everybody's attention was on new development. And no one was looking at all of these tests that we automated and what are they telling us. Remember, we started ignoring them. We weren't maintaining them. We weren't looking to see what information they were giving us. Why did we automate it if we don't even want to look at the information, right? What patterns are being revealed? We didn't look at any of that. And so we really had to get a handle on what we were doing and make sure that we weren't just wasting time automating things, but that we made an effort to look at the information that was being provided to us, that was right here in front of us. And so what we did was we created a ticket in every sprint. And this ticket was to maintain the test, to monitor the bills. And one person would get this ticket per week. So we had 2-week sprints, there would be 2 tickets. 1 week you get it, 1 week you get it. Now this wasn't fun, but we were in really bad shape where we had hundreds of these tests that were failing repeatedly. And so we had to get to a better state, and this was a means to an end. So that person's sole job, that sprint, was to monitor the bills, look at what was failing, determine if it was a bug or a flaky test. Now this became really overwhelming. You have hundreds of things that are failing in front of you. What do you even look at first? So we had to develop another little system, a very simple database, one table. And every test that we executed would report its results to this database. So in here, we would have the time that it ran, an ID of the test, what function was it exercising, the result, was it pass or failed, and the bill number. Given this, we were able to come up with queries, templates, that we can use to help us navigate the cleanup period. So, for example, if I have tests, and all of these hundreds of tests, if I have tests that are exercising our shopping cart functionality, well, that's a critical conversion point in our application. I want to look at those first. So it helped us make better decisions. Maybe there's a test in here that it's its very first time ever failing. Well, that might signal a bug, and so you might want to look at that first. So this helped us out a whole bunch. The farmer and the stork. So there was a group of birds, crane birds, and they would always go to this poor guy's farm, and he planted seeds for the harvest, and they would just eat them up. And every day he would have to go and reseed his crops. And so one day he said, you know what? I'm going to plant a trap for these birds. So the next day, the crane birds were on their way to the farm, and there was a stork that said, hey guys, where are you going? And the crane birds said, oh, we're going to get free lunch. You want to join us? And the stork said, sure, I'll join in. And so they went over to the farm, and the crane birds began to eat. The stork looked, and it didn't feel right. It felt like stealing. And so he didn't partake. But remember, there was a trap there. The farmer had cast a net to catch these birds. And so it caught all of them, the crane birds and the stork. The stork began to cry out and plead to the farmer and say, oh, please, sir, I didn't partake. I didn't know what was going on. Please let me go. The farmer said, no, birds of a feather flock together, so you're just as guilty. Or one red apple spoils the whole bunch. So we were making really good progress with our new system. We were cleaning up these tests. We had maybe 50 cleaned up, and we wanted to celebrate. We would report this at stand-up, and we thought everyone would congratulate us, but they didn't. No one cared. Why? Because the build is still red. I don't care if it's one test in there or 50 tests in there that are red. I still don't trust it. So we decided, okay, we need to make some immediate progress here. So what we did is we separated these tests into two separate bills. The tests that were healthy, that we could trust, they became the tests that were in our CI pipeline. Everything else, the ones that were failing and we couldn't quite get to them yet, or we couldn't figure out what was wrong, those would go in a separate build. Now, we told developers to only pay attention to this build, the healthy build, and we will focus on cleaning up the unhealthy build. We call this the unstable build. Now, we kept these tests running, and they were visible for anyone who wanted to see them. We kept them running for a couple of reasons. We wanted to continue to track the intermittents between them. So remember, they're going into the database, and we can see the ratio of pass and fail on them. And then also, this was technical debt. We wanted everyone to be aware of this. We didn't want to hide it and just remove them or quarantine them, because then, out of sight, out of mind, people think the problem is solved. We wanted to be able to point to this. And the way that we mark these tests is just using our test runner. There's annotations in there so we could put them in a certain group and just have the different groups run on the different builds. And then we also added other fields there, like the test ID in the function area. So this was key for going into the database. Now, for every test that we marked as unstable, we opened a ticket to stabilize it. And this ticket needed to go in our backlog. And it needed to be prioritized with all of the new features, right? So that we weren't only focusing on the new stuff, looking ahead, but we were also taking care of our technical debt. So if we had to put key tests in this backlog, product can see that. Product can see, oh, this is a area around my demo, or this is a cart test, for example. We need to pull that into the next sprint and fix that right away. So this gave us buy-in from the whole team. Also, what was really good is that as we were going through this helped us to keep grooming in check, if you will. So we were able to see what tests did we just blindly automate that was of low value. I can pull those out now. I can probably delete those. Are there tests that I'm just constantly patching and patching, putting Band-Aids on? Maybe I need to refactor that, or is it even worth it? Maybe I can delete it, right? So there was a professor. His name is Atif Mimon. He works at the University of Maryland. And Dr. Mimon, he did a summer at Google. And they assigned him to study their Flaky tests. And Dr. Mimon studied these tests and began to come up with a lot of interesting statistics around Flaky tests. One that I really liked was he noticed that after the third edit of a test, the probability of that test becoming flaky rose exponentially. Thought that was really interesting. So there was one time that I had a test and I was trying to patch it up. Now, I didn't write this test, okay? It was spaghetti code. And it took me a while to even read through it and figure out what is going on in this test. And why is it going through all of this to get to there, right? So I kept trying to patch it to get it to work. And I spent an hour doing this and still wasn't able to get it to reliably pass. Started thinking about Professor Mimon and thinking, I bet I'm the fourth person to touch this test. I'm going to delete it. But I needed the test. It was an important high-value test. So I deleted it, but I rewrote the test from scratch with a fresh mind. I went and made sure I understood what the test case was and then wrote it over. Okay? It took me 25 minutes to rewrite this, where it took me an hour to try to put these Band-Aids on it, and that was unsuccessful. Went from 113 lines of code down to 38 lines of code, right? So don't be afraid to delete stuff when you need to, even if it means just rewriting it in a cleaner way. Last story, the dog and the hare. So the dog and the hare, they wanted to play with each other, and the dog told the hare, I'm faster than you. You want to race? And the hare says, sure, I'll race you. And so they decided to race. Well, the hare was smoking the dog, right? So he was way ahead, and the dog was giving it all his might, and he finally caught up to the hare, and he tackled him. Gave him a little hug. And so they said, oh, let's try it again. They raced again. Same thing, except this time when the dog caught up to the hare, he bit him. The hare said, dude, what's wrong with you? Dog says, oh, my bad, I'm sorry. Let's try again, man. So they race again, and the dog bites him again. The hare says, you know what? I'm done with you. I don't want to play anymore. I don't trust you. I don't know if you are a friend or if you're a foe. Well, we separated our bills, got them in pretty good shape, and the tests were running reliably in the bill that mattered. But we were still automating new things. So as we would add new things to this trustworthy build, they might be flaky or they might fail. And so our developers were going from a state of trusting us to not trusting us. Oh, here they go again with these flaky tests, right? And so we decided that we could make a little private build, especially for people who are new to the team, testers who are trying to get started in coding, tests that we don't really trust ourselves. We think we fixed it, but we can't really get it to break on our machine, right? And so you stick a Band-Aid on it and toss it back over and hope it works. Well, instead of doing that, we had this little private build that could run, and we would essentially make a test prove itself before it could go and run with the big boys, right? And so maybe a test needs to run 10 times successfully before it would graduate into the real build. And we didn't do this for all of our tests, but the ones that we were unsure about, or if we had people who were newer to the team, okay? So how does this story end? Well, we had our 4,000 plus automated tests. We got it to less than 1.5% unstable, which was our metric, because Google's is 3%. So we thought 1.5 is really good, right? And so we made a rule that if that red backlog, that red bill, if it's ever more than 1.5%, we have to stop development, stop everything. It's all hands on deck, and we need to get this back into good shape before we could move on with new code. Oops. Our main bills were always green unless there was an actual failure. So if the product changed and the test needed to be updated, or it was really a bug, then the test would fail. Other than that, it's good to go. And finally, everyone trusted it for feedback. So that's how we got around our issue. Any questions?
Thank you, Angie. Are there any questions around in the room? there we go.
Just out of curiosity, when we have test failures, I would say more often than not, it's not the test that's failing, it's something broken in our infrastructure. I'm curious, in your case, how often was that happening?
So not the app itself, but maybe like the environment. Yeah. Usually only our only environment ones were typically like the weighting. So once we started using the conditional weights instead of the hard-coded ones, we didn't really see very many of the infrastructure issues anymore. It's mostly just the test. What other questions do you have? Everybody's build is beautiful. We have one here.
Oh, there we go.
For your metric tracking the unstable tests, how are you able to, was that something you're able to calculate automatically? Did you have like something set up to make that work, or was it something that was kind of calculated by hand?
You mean like the 1.5%?
Yeah.
Yeah, it was kind of calculated by hand. So at the time that we started this project, it was 4,000 tests. So we said 1.5% of that is 60. If this ever gets more than 60, we would go there. Now, as we added new tests, if it got to like a substantial amount of more, 50, 100 more tests, then we would say, okay, the new number is this. Yeah, by hand.
How do you differentiate those low value or high value tests? How do you know?
I have a whole talk on this, let me tell you. But I've created a matrix. If you're really, really interested, you can go to my site, angiejones.tech, and I have a talk on this. But essentially, looking at the risk, the cost efficiency, the historical data around this functional area. And using this, I've come up with a formula where you can essentially grade each of these tests or score them and be able to tell like which one of these should be automated and which one shouldn't. But that talk is called Which Test Should We Automate? So if you search for that, you should see that talk. Oh, and I'm giving it tonight in itself. So if you want to come through, I can give you the information.
Great, thank you. More questions around in the room?
In the front?
So you must have had buy-in from management. My problem is, so you might have tests that are broken, and you might volunteer some people to fix them, but they have so many other tasks on their plate
Yeah.
that they can't do it all.
Right.
And this is typically what doesn't get done.
Right. So fortunately for us, we knew all along that we wanted to maintain our test, but of course we didn't have that buy-in. The fortunate thing is when product went to demo this and it broke, right? So then all of a sudden management is very invested in getting this solved. So just let something break.
More questions?
Anything else?
Yeah, there we go.
So you spoke about like categorizing the test into two buckets, right? Like the one which is stable and unstable. I'm talking about the development point of view where developers write code in place. Say if it is part of the unstable bucket, so over a period of time, till the actual unstable category is being fixed and moved to a stable category, their code is not being tested and early feedback is not being given. So
Right.
how exactly those cases are being handled?
I love those types of cases because now we aren't the only people invested either, right? So development can see and say, I need those tests running because I'm about to add code around that. And we say, okay. And so product will say, let's move this into that same sprint or the sprint before to make sure that we get those tests back. Or development might even pitch in and fix it themselves.
Thank you. I guess my question is more along the lines of infrastructure. Do you guys keep your automation code and your app code together or in separate workspaces?
This particular project, it was separate. I've worked on some projects where it's all been together.
Now, what is the best practice?
So I won't say best practice. I'll say most common practice is separate. And when the first time I put it together, I wrote an article about it, and everybody was like, "Wow, okay." But some people were like, "What? Everybody doesn't do this?" So those people who said that were mostly developers, and I think they were more thinking of unit tests than the functional test. But common practice, so I've been doing this for 15 years now, and I didn't do my first project together, co-located, until like last year. So every project that I've been a part of or that I've seen people talk about, it's been separate. So at Applitools, yeah, so it's part of the same repository, but I don't work on that anymore. So, yeah. But yeah, the article I can, if you DM me, I can send you a link to like the benefits that I saw from putting them together. There were some interesting benefits there. Yeah.
Great presentation.
Thanks.
You should write a children's book on that or something. I was curious about your title, Senior Developer Advocate. Where does that come from? I apologize. Well, I think I was here at the beginning, but if you already described it, I didn't catch it.
Sure. So I worked in automation for 15 years. In the last couple of years, I've been doing a lot of speaking and writing and workshops and stuff around automation. And recently realized that, hey, this is a whole job. So Applitools grabbed me and said, hey, you can do this for us, where I basically just teach and talk and write tutorials and things like that on test automation and how to do this right. All
More
right.
questions?
Right up front.
Hello. Before you start automating all your tests, I would assume most of them were manual. When you introduced the idea of doing automated tests, did you get any sort of negative feedback from the QA team or testers, maybe thinking that their jobs are in jeopardy because you're now automating?
Yes, but I preach anywhere that I can that we definitely still need testers. So if I come into your shop, you're never threatened because I'm begging for management to keep the QA folks. Like I said, we only need to automate a certain amount of things, but we need to test much more than that, right? I can't automate everything. It's not in the product's best interest for me to spend time in doing that. So I still need the testers to do this whole comprehensive job of testing. I need them to explore the app and do all of this exploratory testing and things like that. It's really two different jobs, and I try my best to make management see that wherever I go. At some point in my career, I wouldn't even take a job if they were getting rid of the QA folks, because I've been down that road and it fails. It doesn't work.
We still have a couple more minutes
One
for
up
questions.
here.
I think with the DevOps kind of movement, more testing is moving into being done by the development group itself. Myself, as a longtime tester and now an automation engineer, I understand how to test things, and I find that the developers have a mindset of proving that it works versus a tester whose mindset is showing where it doesn't work. And I'm wondering if you've observed anything like that, and what you, if so, what you would do about it.
Yeah, only my whole life, right? But yeah, I've worked in development for a couple of years as well, and you're absolutely right. Like, I did automation first, then I went into development for a couple of years, and I noticed like my view changed, like my world view changed. No longer did I have like this big overall picture of the product and how all of these different components work together. It was very tunnel vision on what I was working on. And so I even worked on a team once where we got rid of all of the testers and said Dev would do the testing. So if you and I were on a team, I would work on my feature, you work on your feature, and then we switch, and you test my stuff and I test your stuff. We did a horrible job at testing this stuff because you didn't want to do that. You wanted to move to your next feature, right? And so I have a really big problem with people trying to force tasks on people that they don't want to do or that they don't specialize in. So if you're a developer that doesn't want to specialize in this like comprehensive testing, why would we give that to you to do when it's such an important task to do, right? Now I do think some testing, right? Do your unit testing, do your due diligence or whatever. And I think everyone does that because they want to prove that it works, right? And so you do that amount, but in most cases I've not seen that work very well, where development is charged with doing the entire testing effort.
So there's no more time for questions. Thank you so much,
Okay.
Shanji. If you have any other questions, please contact her directly. Thank you.
Thank you all.